When working with composite functions, it is necessary to understand how function notation works. Across the top of the page, you are given 4 different functions, f, g, h, and j. In the first one, we're being asked to add f of x and g of x together. So I will take f of x of 6x plus 4 and g of x of 4 minus 6x, and I will add these 2 functions together. When you're adding, it's just a matter of combining like terms. So f of x plus g of x will be 6x minus 6x, which cancels itself out, and 4 plus 4, which gives me 8. In number 2, we're finding f minus g of x. So I have f of x is 6x plus 4 minus g of x, which is 4 minus 6x. When subtracting, you have to remember to distribute your negative to everything inside the parentheses. So this will be 6x plus 4 minus 4 plus 6x. So now my plus 4 minus 4 cancels itself out, and I'm left with 12x. And number 3, I'm multiplying f of x and j of x together. So I have f of x is 6x plus 4, and I have j of x is negative 2. When I multiply these 2 functions together, this gives me negative 12x minus 8. And number 4, I am dividing g of x and j of x. So I have g of x is 4 minus 6x, and j of x is negative 2. When I divide 4 by negative 2, that gives me negative 2. And when I divide negative 6x by negative 2, that gives me positive 3x. You may also see this written as 3x minus 2. And number 5, we are finding h of 1/2 and g of 1/2, and we're subtracting them. So h of 1/2 is going to be 2 times 1/2 when I replace my x and h with 1/2. And I'm going to subtract 4 minus 6 times 1/2, where I replace my x and g of x with 1/2. 2 times 1/2 is 1, and I'm subtracting 4 minus 6 times 1/2 is 3. So this is 1 minus 1, which gives me 0. And number 6, I'm finding f times g of negative 1/6. So I have 6 times negative 1/6 plus 4 for f of negative 1/6, where I replace the x with negative 1/6, times g, which is 4 minus 6 times negative 1/6, when I replace the x with negative 1/6. And I'm going to simplify these down. So 6 times negative 1/6 is negative 1 plus 4. Negative 6 times negative 1/6 is positive 1, so 4 plus 1. This gives me 3 times 5, and that leaves me with 15. In the next set of examples, you're doing the same thing. We're finding f plus g of x, but we're given 4 new functions, f, g, h, and j. So I'm going to add x squared plus 10x plus 5. And if I can combine like terms, then I do. And number 8, I have x squared minus 10x plus 5. So I have to remember to distribute that negative. So this is x squared minus 10x minus 5. I'm finding f times j of x again. So I have x squared times j of x is 5. So this becomes 5x squared. In number 10, I'm dividing j and g of x again. So this is 10x plus 5 over 5. 10x divided by 5 is 2x. 5 divided by 5 is 1. In number 11, I'm finding h plus j of 49. Well, h is the square root of x, and x is 49. So the square root of 49 plus j of 49. J of x equals 5. This is a constant function. A constant function always has the same value of y, regardless of what I put in here for x. So even if I put 49 in for x, j of 49 is still equal to 5. The square root of 49 is 7. And when I add 7 and 5, that leaves me with 12. In number 12, I'm multiplying f of 4 times h of 4. So f of 4 is going to be 4 squared times h of 4 is going to be the square root of 4. 4 squared is 16, and the square root of 4 is 2, and 16 times 2 gives me 32. In numbers 13 through 15, you're given f of x, and you're asked to find g of x so that the given statement is true. This says f of x plus g of x needs to equal x squared plus x plus 6. Well, I know what f of x is. It's x plus 2. So x plus 2 plus g of x has to equal x squared plus x plus 6. So I'm going to subtract my x plus 2 because I need my g of x by itself. So that gives me g of x equals x squared plus x plus 6 minus x plus 2. When I distribute my negative, this is x squared plus x plus 6 minus x minus 2. And when I combine like terms, I find that g of x is equal to x squared plus x minus x cancels itself out, and 6 minus 2 becomes positive 4. And number 14, this means f of x divided by g of x needs to equal 1/4. Well, again, I know what f of x is. F of x is x plus 2 divided by g of x has to equal 1/4. Well, this is a proportion, so I'm going to cross multiply. So this is 4 times x plus 2 is equal to g of x, and g of x is equal to 4x plus 8. And number 15, this means f of x times g of x needs to equal x cubed plus 2x squared minus 9x minus 18. I know what f of x is. I need to find g of x so that it equals x cubed plus 2x squared minus 9x minus 18. So when I divide both sides by x plus 2, I have x cubed plus 2x squared minus 9x minus 18 over x plus 2. Well, this is a rational expression. Whenever you reduce down rational expressions, you want to factor everything that can be factored. So I'm going to factor the top part of this expression. This gives me g of x is equal to, this will be x squared minus 9 times x plus 2 over x plus 2. And if you recall from the previous unit, when you simplify a rational expression, you cancel out the terms that are the same on the top and the bottom. So that leaves me with g of x is equal to x squared minus 9.